The universe is full of wonders, astonishingly beautiful, deeply mysterious, and at times unimaginably terrifying. It stretches beyond human comprehension, filled with vast galaxies, swirling nebulae, and a silent darkness punctuated by the brilliant light of stars. Among the most awe-inspiring and enigmatic phenomena in the cosmos are the remnants of stars that have reached the end of their life cycles, objects that exist at the very limits of known physics. These are the dead or dying cores of stars, pushed to extremes by the passage of time and the inevitability of gravitational collapse. They go by names like pulsars, neutron stars, and magnetars, terms that may sound exotic, but each represents a chapter in the story of stellar evolution, a tale shaped by forces that defy ordinary imagination. These remnants are not just isolated, cold celestial bodies drifting silently through the void. They are dynamic, often violent, and always powerful. They are cosmic relics, monuments to the fundamental laws of nature stretched to their breaking point. Each one is a reminder of how physics behaves under the most extreme conditions the universe can offer. In many ways, they are laboratories of the impossible, offering us rare glimpses into a reality where gravity, magnetism, and quantum forces collide. Consider a massive star nearing the end of its life. For millions or even billions of years, it burns through its nuclear fuel, fusing lighter elements like hydrogen and helium into heavier elements such as carbon, oxygen, and eventually iron. But iron is the end of the line. Unlike earlier fusion reactions, which release energy and hold the star up against gravity, fusing iron consumes energy. And so, when the core is mostly iron, the outward pressure from fusion can no longer counterbalance the inward pull of gravity. At this tipping point, the star faces a dramatic fate: catastrophic collapse. As the star runs out of fuel, it begins to implode under its own weight. This implosion is unimaginably fast and intense. Within seconds, the core collapses, crushing protons and electrons together to form neutrons. What remains is a neutron star, an object so dense that a single teaspoon of its material would weigh billions of tons. The collapse halts only when the neutrons themselves exert a quantum pressure that resists further compression. This is one of the densest forms of matter in the universe. Sometimes, these neutron stars are born spinning rapidly, dozens or even hundreds of times per second, thanks to the conservation of angular momentum. They emit beams of electromagnetic radiation from their magnetic poles, and as they spin, these beams sweep across space like the beams of a lighthouse. If one of these beams happens to point toward Earth, we see a pulse of light at regular intervals. These are pulsars, cosmic clocks that pulse with extraordinary precision, often more accurately than the best atomic clocks on Earth. But if conditions are even more extreme, if the magnetic fields during the collapse become unbelievably strong, we get something even more exotic: a magnetar. Magnetars possess magnetic fields up to 1,000 trillion times stronger than Earth's. These fields are so intense that they can twist and rupture the surface of the star, releasing enormous amounts of energy in violent flares. These outbursts are capable of disrupting satellites, communications, and even power grids if they occurred close enough to Earth. Fortunately, the nearest known magnetars are thousands of light years away, but the sheer power they wield, even from such distances, is a testament to the untamed forces at play in the cosmos. Yet, despite their immense power and the cataclysmic events that form them, the threat these objects pose to Earth is often exaggerated. The universe is vast, and the scales of time and space it operates on are almost beyond human comprehension. Even if a magnetar were to erupt in our galaxy, its radiation might take thousands, or tens of thousands, of years to reach us. And by the time it does, the intensity may be significantly diminished. If such an event has already occurred, the signals could still be racing toward us through the emptiness of space, undetectable until they finally arrive. To bring this concept closer to home, consider Betelgeuse, a red supergiant in the constellation Orion and one of the brightest stars in our night sky. It is enormous, beautiful, and nearing the end of its life. Astronomers have watched Betelgeuse with fascination, especially during episodes when its brightness dims unexpectedly. These changes have sparked speculation that it might explode in a supernova at any moment. But in the language of the cosmos, any moment could mean thousands, even tens of thousands of years. Eventually, Betelgeuse will explode. When it does, it may shine brighter than the full moon, visible even in daylight for weeks or months. But despite its size and spectacle, Betelgeuse lies over 600 light-years from Earth. Its light and any radiation released during its explosion will take centuries to reach us. And by the time it does, the supernova's most harmful effects will have dissipated. What we will witness is the light echo of an ancient death, a brilliant finale in the sky that poses no threat, only a reminder of nature's grandeur. Pulsars and magnetars, meanwhile, are remnants of stars even more massive than Betelgeuse. When they collapse, they form objects only about 20 kilometers across, roughly the size of a city like Manhattan or Paris, but with masses greater than the entire Sun. To imagine this is to try to grasp the impossible, compressing the entire mass of the Sun into a sphere no larger than New York City. In such a scenario, gravity, density, and magnetic fields reach levels so extreme that the behavior of matter becomes almost alien. At these densities, atoms themselves are crushed and matter exists as a sea of neutrons. Betelgeuse, for all its vastness, would be dwarfed in power by the core of such a neutron star. If Betelgeuse were placed at the center of our solar system, it would engulf Mercury, Venus, Earth, Mars, and possibly Jupiter. Yet a neutron star, a mere speck by comparison, contains more mass, more gravity, and vastly more concentrated energy. And magnetars? Their magnetic fields are so intense that they could theoretically erase data from credit cards or hard drives from halfway to the moon. These stars, neutron stars, pulsars, and magnetars, teach us something profound. They are not just cosmic curiosities or astrophysical oddities. They are proof that the universe is not a gentle or predictable place. It is a realm of extremes, of forces beyond intuition. It is where pressure can crush matter into unfamiliar forms, where gravity can curve space and time, and where light and radiation burst forth in ways that stretch our understanding of energy and time. They remind us that the cosmos runs on principles that are raw, unyielding, and often awe-inspiring. It is not tailored for comfort. It is not designed for safety. It is a place of endless change, endless violence, and endless beauty. So, the next time you look up at the night sky, especially at bright giants like Betelgeuse, remember that you are looking into the past, gazing at light that began its journey across space hundreds of years ago. You are witnessing stories written by time, distance, and unimaginable forces. These stars, though dangerous in theory, are mostly distant and ancient, and yet, in their deaths and their remnants, they tell us something beautiful: that the universe is a place of constant transformation, and through its most extreme phenomena, we can better understand our place in the cosmos. Dangerous? Yes, but also breathtakingly beautiful. Because in the ashes of stellar destruction lies the story of creation, the ongoing saga of a universe that is not just vast, but deeply alive with energy, power, and wonder. Thanks for joining this journey through space and time. If you found this exploration inspiring, be sure to like, subscribe, and tap the notification bell so you don't miss what's next. Because out there, in the darkness between stars, the universe is still unfolding. And it's waiting to be discovered.